Hey there, let's talk about number properties. In this session, we'll cover the commutative and associative properties as well as some properties of equality. The commutative property states that the order in which we add or multiply real numbers does not affect the result. So, for any two real numbers a and b, a plus b equals b plus a, and a times b equals b times a. Let's look at a couple examples. By the commutative property of addition, 5 plus 3 equals 3 plus 5. The expressions 5 plus 3 and 3 plus 5 both equal 8, so it makes sense that they equal each other. By the commutative property of multiplication, 4 times 6 equals 6 times 4. The expressions 4 times 6 and 6 times 4 both equal 24. Therefore, it makes sense that they equal each other. The associative properties say that the way numbers are grouped does not affect the result. For example, for all real numbers a, b, and c, when you take the sum of the quantity a plus b and add that to c, that equals a plus the sum of the quantity b plus c. Also, when you take the product of a times b and multiply that by c, it's equal to a times the product of b times c. Let's look at a couple examples of the associative property. The first example demonstrates the associative property of addition. The expressions on both sides of the equal sign sum the values 3, 4, and 6. On the left, 4 and 6 are grouped together, and on the right, 3 and 4 are grouped together. In both cases, the sum is 13. Therefore, it makes no difference how the numbers are grouped. The sum is still the same. This second example demonstrates the associative property of multiplication. The expressions on both sides of the equal sign multiply the values 2, 4, and 5. On the left, 4 and 5 are grouped, and on the right, 2 and 4 are grouped. In both cases, the product is 40. Therefore, it makes no difference how the numbers are grouped. The product is still the same. These aren't proofs of these properties, but it is comforting to verify that the properties really do work. All right, here's our first problem. Let's name the property that is demonstrated in this equation. When we look at the expression on the left versus the expression on the right, we see that the numbers are grouped differently. The sum of 4 and 18 is grouped on the left, and the sum of 12 and 4 is grouped on the right. The property that tells us that it doesn't matter how we group numbers when adding them is the associative property of addition. All right, here's another problem. Let's name the property that is demonstrated in this equation. Again, compare the expression on the left with the expression on the right. We see that the numbers are being multiplied in a different order in the two expressions. We have 12 times 6 times 15 on the left, and 15 times 6 times 12 on the right. The property that tells us that order doesn't matter when multiplying is the commutative property of multiplication. Here's another one. Let's name the property that is demonstrated in this equation. Looking at the expressions on the left and the right, we see that the same quantities are being added on both sides, but the order in which they're being added is different. The property that tells us that order doesn't matter when adding is the commutative property of addition. All right, and here's another one. Let's name the property for this equation. In this problem, the values that are multiplied on the left are also multiplied on the right. The only difference between the expression on the left versus the expression on the right is the way in which the values are grouped. In the expression on the left, 8m and 5n are grouped, and the product is then multiplied by 10. In the expression on the right, 5n and 10 are grouped, and the product is then multiplied by 8m. The property that tells us that it doesn't matter how values are grouped when they're multiplied is the associative property of multiplication. Here are three properties of equality: the reflexive property, the symmetric property, and the transitive property. Let's go through each one. The reflexive property tells us that for all real numbers a equals a. Basically, this tells us that any value is equal to itself. For example, 3 equals 3. All right, that seems pretty silly, but some mathematicians really care about being very rigorous about stuff like this. The symmetric property states that for all real numbers a and b, if a equals b, then b equals a. For example, if x equals 5, then 5 equals x. And finally, the transitive property states that for all real numbers a, b, and c, if a equals b and b equals c, then a equals c. For example, if m equals 4 and 4 equals n, then m equals n. Let's try this next problem. Let's name the property that is demonstrated in this sentence. If x plus 2 equals 5, then 5 equals x plus 2. In these two equations, the left and right sides trade places. Therefore, this demonstrates the symmetric property. All right, here's another one. Let's name the property that is demonstrated in this equation. The property that states that any quantity is equal to itself is the reflexive property. All right, here's our last problem. Let's name the property that is demonstrated in this sentence. If n equals 8 and 8 equals p, then n equals p. This statement follows the pattern: if a equals b and b equals c, then a equals c. Therefore, this sentence demonstrates the transitive property. So, what have we covered? The commutative property states that the order in which we add or multiply does not affect the result. The associative property states that the way we group numbers when we add or multiply does not affect the result either. The reflexive property states that any real number a equals itself. That means a equals a. The symmetric property states that for all real numbers a and b, if a equals b, then b equals a. And the transitive property says that for all real numbers a, b, and c, if a equals b and b equals c, then a equals c.